Hey guys, so these are some video instructions for the vector addition activity. Now, obviously, my intent is that I want you guys to finish the height sight activity, but if you do make it to the vector addition activity, then this is something that you can start working on. So I did mention vector addition in class. And the slides that I posted on Tuesday, they go over the technique for adding vectors. But I'm going to go ahead and talk about it now. And I'm also going to show you guys using the simulation. And so this activity uses the simulation. A URL is right here. But if you go ahead and just type into Google vector addition interactive, it will post, come right up. And it's on the Physics Classroom website, which, if you haven't been to it before, is a super handy website for all sorts of like definitions and concept builders and whatnot. So look around the website, but in the meantime, for the instructions for this video, you guys will use that in addition to the arrow feature on Google Slides to do your vector addition. So the directions say below. So for each problem, vectors A, B, and C are shown. So here's problem 1, for example. Sketch the head to tail addition of A plus B to C on the empty grid. Label each vector, and then go ahead and draw and label the resultant. Record the magnitude and direction of each component. Use a positive sign to indicate east or north. Use a negative to indicate west or south. And then the sum of the components to determine the components of the resultant. So use the Pythagorean theorem and SOHCAHTOA, which is just a handy way of remembering which one is sine, cosine, tangent, to determine the magnitude and direction of the result. So here's an example, and I'll go ahead and do the first one with you, and then if you guys could continue working, that would be great. So you'll see right off the bat that we have a vector, and vector A is 2 by 1, 2, 3. Okay, so if you guys come over here and you click on your arrows, you can go ahead and replicate that vector. So I'll start down here so that I know that I have plenty of space, but I'll go 2 over, and then I'll go 3 up. So 1, 2, 3. Okay, and that is going to be my vector A. Now, if you want to make your life a little bit easy, you can go ahead and you can make it blue. You could also make it a little bit thicker so that you can see it a little bit better. Okay, so we got A. Now let's go ahead and do B. Now, the method for adding vectors is going to be what's called tip to tail. So how that's going to work is you're going to literally take the tail of B and put it on top of the tip of A. So let me show you an example. So you can see that for B, it is 1, 2, just to the right. Okay. And so let's go ahead and let's get an arrow. And we're going to put it right here. And we're going to go over 2. So 1, 2. Okay. And there's our second. So let's go ahead and make it, as I did in the last one, a little bit thicker. And let's make the color a green. Okay. So you guys have officially added A plus B. Okay. And so now let's go ahead and add C. We're going to follow that tip to tail method, literally the same thing. So this one's going to be 1 north, and then 1, 2, 3, 4, 5, 6, 7. So 1 up, 7 to the right. So let's go ahead and draw that arrow. So we're going to go 1 up, then 1, 2, 4, 5, 6, and 7. So come over there. realized I should have done that. So 1, 2, 6, 7. Here we go. And then let's go ahead and increase the thickness and change it to a reddish color. Okay, so we've now officially added the vectors, and in order to get the resultant, you're going to go ahead and draw the resultant from the bottom of A all the way to the end of C. Okay, so let's go ahead and do that. So we'll draw a new arrow. We'll start at the bottom of A, and we'll go all the way to the end of C here. Let's make it a little bit thicker than the last one. Let's make that one black. Okay, so that black arrow is going to be our resultant vector. Okay, now we could go ahead and we can measure the components. We could go ahead and fill in the table. So let's start off with filling in the table. So for A, the east-west components, this one had a positive 2 to the west. So let's go ahead and put that in. And obviously you can fast forward if I'm talking a little slow. Okay, the placement's not super important. And then the north-south is that it went up 1, 2, 3. Okay. And actually, I don't need to do that. I could just copy and paste that. Okay, so here. And then you would continue, right? So B had only east-west components. So this one is going to be 2 to the right. And then it's going to be 0 in the north and south direction. Okay. Okay. And we could go ahead and do C. That one was 1 up, 7 to the right, if I remember correctly. Okay. And then very lastly, we're going to go ahead and do the resultant. So you can go ahead and just measure the resultant. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 to the right. And 1, 2, 3, 4 north. So let's go ahead and put that. Okay. So we got 10 to the right. Okay. And then we got 4 north. Okay. Very good. All right. So here's what we can go ahead and do now. So you'll notice that the next two questions are going to ask you to calculate the magnitude of R. Now, the way that we could do that is you have the east-west component and you have the north-south component, right? So for example, let me go ahead and draw some more of these arrows. We know that we have a triangle that goes 10 to the right, and we know that we have another component that goes 4 up. So that right there is our right triangle, right? you can actually use the Pythagorean theorem, and that's why it hints right here, the Pythagorean theorem, right, to go ahead and you can solve for that. So let's go ahead and do that. I'm going to go ahead and open a Desmos tab. Okay. Oops, Desmos. We'll use the scientific calculator. Okay. Okay, and let's go ahead and write the Pythagorean theorem. So we got a squared plus b squared is equal to c squared, right? And c is going to be our resultant, our hypotenuse. And so c, right, is going to equal to the square root of a squared plus b squared. Okay, great. Let's go ahead and define that. So a is going to be the first side. So let's go ahead and go back to what we had. So a was 10 to the right, and then b was 4 up. So let's go ahead and write a is equal to 10, and b is equal to 4. And there you go. We get an answer solving for the Pythagorean theorem for us. 10.77 is going to be it. So let's go back over here, and let's go and plug that in. We're going to have 10.77. You can round it up if you want. Let's just say 10. Okay, now how are we going to find out the direction? Now, you could go ahead and you could use any of the sides. So let's go ahead and we have A, we have B, we have C. We can use any of the trig functions. Let's just go ahead and use sine. So we'll say that the sine of x is going to equal to, right? Um, sorry, I'm blinking. The opposite over the hypotenuse. And so let's go ahead and grab the opposite. So the opposite is going to be 4, and then the hypotenuse was 10.8. And so let's go ahead and do that. So we're going to say 4 divided by 10.8. Okay, and now we need to rearrange that a little bit. And so if I was to go ahead and solve for that, I'm just kind of using that line as a placeholder. You would need to take the inverse sine of 4 divided by 10.8 to go ahead and solve for what x is. So I'm going to go ahead and say that x is equal to a sine, or you could say arc sine, of 4 divided by 10.8. Arc sine just means the inverse. Okay, and I get an angle of 21.7, which is great. Okay, so 21.7, let's go back and go over here. Let's go ahead and copy and paste this text. Okay, and this is going to equal to 21.7. I'll put a degrees. Okay. And that's that. That's how you would answer it. So the components are over there on the left-hand side. The math is over on the right. And you can see that I just went ahead and I used the graph paper in order to solve it. Now, what's really nice, you'll notice that I never used the simulation, and you actually don't really need to use the interactive, but the interactive is nice because it does the math for you. So for example, I'm just going to make some samples. Let's say that this is A. And let's say that I want to go 3 up here. And here's B. Let's go ahead and put B. Let's make it go all the way over here. And then here's C. We'll make C go, I don't know, let's make C go down here. What you can do, once you've put A, B, and C together, you've added the vectors, you can say, show me that resultant, and it'll go ahead and it will show you the resultant right here. And on top of that, you can go ahead and say, show me the components. Oops, which is super nice. And there used to be a button. Yes, and it tells you right here. So it'll tell you that, you have the magnitude right here of your resultant. Your resultant's magnitude is 9.5, and the angle is 18.5 degrees. And so this is really handy for that sort of thing. You can also hide the resultant, and it'll still tell you, like if you click on each of them. Oh wait, it's not doing it right now. But in general, you should be able to click. It usually just, I guess it just gives you the resultant in this one. But it's still a super powerful feature because it will pretty much do the Pythagorean theorem, and then it will do the trigonometry for you. So I'll let you guys decide what you want to use and go from there. All right. Once you guys finish, so I did the first problem for you. You'll notice that there's two more. So we got problem 2, problem 3, problem 4, and then you guys will be, in my opinion, experts in vector addition. Okay. Feel free to message me on Canvas or by email if you guys have any questions. And yeah, I'll see you guys on Thursday. Take it easy.